Hello, geometry students. So today we are going to continue our study of area, and we're going to focus on trapezoids and kites. So you should have this page ready to attach to your notebook, so glue or tape it down. Again, the last thing we had added was area of triangles, parallelograms, and the rhombus. So at the top here, if you have room, I'm going to write down area of trapezoids and kites. And just a reminder, if I am going too fast, pause the video to catch up and then pick back up. And again, a nice reminder to not only watch but listen, please, to the video. So again, watch and listen to the video. So starting off with a trapezoid. So if we're looking at a trapezoid, if you remember back from first semester what it looks like, so we could draw a picture, I don't know, something like this. Remember, in a trapezoid, you have one pair of opposite sides that are parallel. Those are your bases. They are different lengths. They are never going to be the same length. And the height is going to be a perpendicular segment that is going to go from one base to the other. So there are two formulas we could possibly use, I should say, for area of a trapezoid. One of them is maybe I should say, if you look back on your area wheel, let's see here, trapezoid right over here. So we have two of them listed here. The most likely, the one you're going to use most often is going to be the second one here. Area is 1/2 the height times the sum of the bases. Get to the correct page here. So instead of using 1/2, if you'd like to just say the height times the sum of the bases and divide by 2. Again, B1 and B2 are going to be the two different bases that you have. Again, they're never the same. They are always going to be different. The other option that you see on that page, and again, if I flip back to that, okay, so again, the other formula was capital M times H. Capital M represents the median, the length of the median, and again, H is your height. So if I go back to my picture here, and again, I draw another example. So this is again your height. The median is going to go from the midpoint of one leg to the midpoint of the other. That is the median. So again, your other option is taking the length of the median times the height. Now the reason that we have two options is because if you remember back from first semester, how we find the median, it's the average of the bases. So this part right here, B1 plus B2 divided by 2, that is the same thing as your median. So again, it's median times height, or work it out with, again, the height times the sum of the bases divided by 2. Either one is appropriate. It just depends on what you're given. So if we look at the different examples, the first one, that's in your notes, says to find the area of a trapezoid with a height of 42 inches and bases of 8 inches and 10 inches. So again, they give us the height and they give us the two bases. So again, thinking about that area formula that I still have on my page here. Again, it's the height times the sum of the bases, and I'm going to divide by 2. So if I plug in a height of 42 inches, and I plug in bases of 8 and 10, and again, I have to divide by 2. So again, doing order of operations, I'm going to do my parentheses next. 8 plus 10 is 18. So I'm going to take my calculator. I'm going to type in 42 times 18. And I'm going to divide that by 2. So I get an area of 378. And area, remember, is always in square units. So it would be square inches. So again, this one, I just use the formula. Now, on the second one, I put this problem back in. This is a problem we did the other day, and I'm going to refer back to it in just a minute. So again, it says to find the area of the trapezoid below. Notice in this picture, this 6.2 inches is my height. It's a perpendicular segment that goes from one base to the other. One of my bases is going to be 11.6 inches. I'm just going to call that my B1. My other base is 6.1 inches, so I'm going to call that B2. So again, if I plug it into this area formula, area equals, my height is 6.2. My bases, again, are 11.6 and 6.1. So if I, again, do that calculation, the first thing I'm going to do is parentheses because of order of operations. So again, I have 6.2 from here. I'm going to multiply that by 17.7 and then divide by 2. So I get 54.87, and I'm in inches, so it's going to be square inches. So again, I use the formula that we had for a trapezoid to help me find, again, this area. So again, I said the answer was 54.87. Now, again, I want to show you that we actually did this problem earlier this week, or I'm sorry to say last week, and I want to show how we did the area then, and we're going to compare the two. So again, this is what the formula. If you look back, where is it at? Right here, this is my same problem. Notice it says find the area of the trapezoid below. This was the trapezoid, and remember when we did it, we either split it up into two triangles or we did a rectangle and a triangle. But what do you notice? I still got that same area, 54.87. So if you would rather split it up into pieces, that is always a possibility. We got the same result. Notice 54.87, 54.87. So again, it kind of depends on how you want to approach it. Okay, moving on to the next one. It says to find the height of a trapezoid with an area of 64 square feet and bases of 6 feet and 4 feet. So again, if we think about our area formula, it's the height times the sum of the bases divided by 2. So I am going to plug in what I know. It says the area is 64 square feet. So I'm going to plug 64 in place of the area. I do not know the height, so I'm going to keep it as h. Notice the directions said to find the height. I do know the two bases. One is 6 and one is 4. So now I'm just going to continue to work this out. Again, the first thing I'm going to do is parentheses. That comes from order of operations. So I'm going to say 64 equals h times 10 divided by 2. And again, the 10 comes from 6 plus 4 gives me 10. Okay, the next thing I'm going to do is I'm going to simplify this a little bit. 10 divided by 2 is something I can do here. 10 divided by 2 is 5. So I'm going to say 64 equals h times 5, which is the same thing as 5 times h. And then to finish, to solve for the height, we're going to divide both sides by 5. So if I take 64 and divide it by 5, I get 12.8. So my height is going to be 12.8 feet. So again, I knew the area, I knew the bases, I wanted to work backwards and figure out what the height was supposed to be. Okay, if I continue on with the last one on the left, it says to find the area of the trapezoid below. Okay, so I have a couple different options for this one. So if I'm looking at this picture, I should be able to identify that the height is the 8-meter segment. Again, a height is a perpendicular segment that goes from one base to the other. One of my bases is 7.6. I'm going to call that B1. Okay, to find the other base, again, it's going to go from one end all the way to the other. So to do that, I'm going to add these two pieces together, the 13.2 and the 7.7. So that gives me the other base, B2, is going to be 20.9. Again, all I did was add these two pieces together to go all the way across. So if I use my formula, area equals height times the sum of the bases divided by 2. We know the height is 8. My two bases are 7.6 and 20.9. And again, I'm going to multiply 8 times their sum and divide it by 2. So if I work this out, 7.6 plus 20.9 is 28.5. Oops. And I'm going to divide that by 2, not by 5. I accidentally wrote that down wrong. Okay, so again, working this out, we're going to take 8 times 28.5, and we're going to divide that by 2. So my final answer for the area of this trapezoid is 114 square meters. Now again, remember I said there's other ways you can do this problem. This would be by far the quickest way, in my opinion. The other way to do it would be to split it up into 3 sections. To split it up into a triangle here, a rectangle in the middle, and then another triangle on the other side. Let me just use a different color here. Let me grab the blue. So again, that would be option number 2. Okay, to do this, I would again find the area of each section and add them together. So this middle, like I said, is a rectangle. The dimensions are 8 by 7.6. So if I take 8 times 7.6, I get 60.8. To find this orange triangle, remember area of a triangle is base times height divided by 2. This height here that I'm pointing to is also going to be 8 meters. So again, if I take my calculator and take 7.7 times 8 and divide it by 2, this triangle here is 30.8. And then to find this last triangle over here, the height is 8. To find the base, I would take this section from here to here, which is 13.2, and I would subtract off that 7.6. That would leave me with this ending piece being a length of 5.6 meters. So again, to find the area of that triangle, I would take 5.6 times 8 and divide it by 2. So this one has an area of 22.4. So again, to find my total, I would just add them together. 22.4 plus 60.8 plus 30.8. And again, that gives me the same answer of 114 square meters. So it is an option to split it up into pieces. That is not the only way you can do it. Again, I would say the quickest way is with the formula, but you do have an option. Okay, on the right side, I would like to do the second problem here first, and then we'll go back up to the top one. It says to find the area of a trapezoid with a median length of 14 meters and a height of 9 meters. So we did say in the beginning here that one of the formulas we have for area of a trapezoid is median times height. And I want to use that because in this problem, I know the median and the height. So again, if area is median times height, we know the median is not 9, I'm sorry. The median is 14 and the height is 9. So if I take 14 times 9, that gives me 126. And since area, again, is in square units, it's going to be square meters. Okay, now with the one at the top, remember we had talked about last week that some of the problems are going to require us to use Pythagorean theorem to find a missing dimension so that we can then calculate the area. We're going to see that at the top. If you have a problem in your homework that's going to talk about isosceles trapezoids, most likely you're going to be using it then as well. So on this particular problem, it says find the area of an isosceles trapezoid with legs 5 inches and bases 6 inches and 14 inches. So I'm going to draw a picture. Remember an isosceles triangle, an isosceles trapezoid is a trapezoid that has, it's a trapezoid obviously, but it has congruent legs. So in this picture, these are my legs. They're both going to be 5. My shorter base is 6 and my longer base is 14. So again, if you think back to this area formula here, area is height times the sum of the bases divided by 2. I don't know the height. The height is not 5, but I do know the bases are 6 and 14. But again, I am missing this height. That's what we need to find. So to do that, what we're going to do is draw in a height. We're actually going to draw in two heights. We're going to draw one in here, and we're going to draw one over there. So we have now split this trapezoid, this isosceles trapezoid, into three sections. We have a rectangle in the middle, and then we have two right triangles on the end. Now again, keep in mind, we are missing the height here in our formula. So considering the fact that we split it into a rectangle, that means this middle section here has to have a length of 6 because the top was 6. Now, since the bottom base is 14 all the way across, if I take 14 minus 6, I'm left with 8. So if both end sections have to add up to be 8, that's going to tell you that they're each going to be 4. Because 8 divided by 2 is 4. So now, if I want to find the height, I can use Pythagorean theorem. I have this right triangle over here. And again, Pythagorean theorem tells me that a squared plus b squared equals c squared. And in this situation, the hypotenuse, which is c, is going to be the 5. It's the side across from your right angle. So we are going to do h squared plus 4 squared equals 5 squared and work it out. 4 squared is 16 and 5 squared is 25. If I'm going to continue to solve for h in this case, I'm going to subtract 16 from both sides. 25 minus 16 is 9. And then to finish it off, we are going to take the square root of both sides. And we should all know that the square root of 9 is 3. So again, 3 is not the final answer to my problem. The 3 is referring to the height. So in my formula, if you remember, I was missing the height. So since I know the height is 3, I'm going to plug that in there. So working through the formula here, we've got 3 times, again, we're going to do parentheses first. So if I take 6 plus 14, that is 20. So to finish my calculation, I'm going to take 3 times 20, which is 60, and divide it by 2. My final answer is going to be 30 square inches for this trapezoid. Now, like I had mentioned, this is not the only way you can do this problem. You could split it up into pieces and then add them all together. And what I mean by that, this middle section is a rectangle. The dimensions are 6 by 3. You still have to use, maybe I'll pause for a moment here. You still have to use Pythagorean theorem to find your height. That's not going to be an option to skip. But since I know this is 3, this middle rectangle would be 3 times 6, which is 18. To find either end triangle, remember area of a triangle is base times height divided by 2. So the base is 4, the height is 3. 4 times 3 is 12. 12 divided by 2 is 6. So that means this one over here is also 6. And if I add them together, 6 plus 6 is 12, and 12 plus 18 is still 30. So it is up to you if you want to use the trapezoid formula or if you want to use the formula for the rectangle and the triangles and piece them together. That is your choice. You have to use what works better for you. Okay. So I'm going to continue on now with the kite because the focus again today was on area of trapezoids and kites. So for a kite, if I flip back again to my area wheel, my kite is right here. Remember, in a kite, you have 2 short sides that are congruent and 2 long sides that are congruent. And notice on this picture here, I have this diagonal labeled as D1, this diagonal here labeled, I'm sorry, the first one I have labeled as D2, the second one here is D1. You could make one of them D1, the other one D2. It doesn't matter which one's which. But the formula we have for a kite is actually the same one we have for, remember, a rhombus that we did the other day. So again, you're going to multiply the 2 diagonals together and either take half of it or divide it by 2, whichever is your preference. So again, if I'm going back to my example here, maybe let's just draw it real quick. So here's my kite. And again, we have one diagonal here. This would be like my D1, and here's my other diagonal. This one would be my D2. So I'm going to multiply them together and divide by 2 or take half, whichever is your preference. You should notice I have 2 examples here below of a kite, on a kite. So on the first one, if I shift up just a little bit, it says to find the area of a kite with diagonals of 13 feet and 10 feet. Again, I know the 2 diagonals, so I'm going to use my formula. Area equals D1. I'm going to make one of them 13, and the other one it says is 10. So all I'm going to do is take 13 times 10, which is 130, and divide it by 2. That gives me 65, and it's going to be square feet because, again, area is always in square units. I'm just using the formula. You just got to know which formula to use and when you are using it. I have one final example to go through on a kite. The problem states if a kite has an area of 100 square feet and one diagonal of 40 feet, how long is the other diagonal? So again, it comes back to area equals D1 times D2 divided by 2. So I'm going to plug in what I know. I do know the area is 100. So again, where I have an A here, I'm going to plug in 100. I'm going to let 40 be the first diagonal. I'm going to call the other one just D. You can call it D2 if you like. And again, I'm going to divide by 2. So my next step, algebraically, would be to take 40 and divide it by 2. And we know that 40 divided by 2 is 20. So if I have 100 equal to 20D, to solve for D, I'm going to divide both sides by 2. So my other diagonal is going to be 50 feet. And again, if I wanted to check it, 40 times 50. Oh, hold on, I made a mistake here. Hopefully you caught that. 40 divided by 2 is 20. I don't know if I said 2 or 20. Let's go back there a second. So if I divide both sides by 20, my answer is not 50. I apologize for that. My answer is 5. So again, you got to pay close attention to your answer here. So let's try this one more time. So to find the area, or to double check my math here, if I took 40 times 5, that is 200. And then if I took 200 and divided by 2, I do get 100. So my answer would be correct. So again, be careful with your steps. So today's assignment is on trapezoids and kites. You will have a worksheet, so make sure you're working on that. If you did not yet finish the area of triangle, parallelogram, and rhombus worksheet from last week, make sure you're doing that first, okay? And if you have any questions, please let me know.